Hello and welcome to Building Insights. I'm James Parker, editor of Architects Datafile magazine. This podcast is brought to you in association with Vmzinc. Today, I'm once again joined by Jonathan Lowy, Operational Marketing Manager at Vmzinc. It's always a pleasure to speak to John. This time last year, we spoke about zinc and its place in architects' hearts. But today, we're talking about performance specification. What is it? Why is it crucial to aim for full performance specifications to get roofing and cladding spec right? How can it guard against value engineering? And how there are no bad products, just inappropriate uses? Hi John, it's great to speak to you again. I think it's about a year since we last spoke more about the general benefits of zinc and its place in architects' heart. I think we spoke about in 2024, and really more of a focused chat today about the importance of performance specification.
Yes, hello James. Yeah, good to be back and talking about all things zinc. Performance spec. I mean, it always has been important for lots of reasons and lots of people. I mean, a number of architects want to write a performance spec, which is entirely understandable, and we try to support them with as many aspects of that, whether it be information on certification, installers and their skill set required, as well as information on the aesthetics. It's clear that zinc is often chosen by designers and architects for durability, low maintenance, but aesthetics are always important. It's the outside of the building, it's the roof or the wall, it's extremely visible, and the aesthetic element is fundamental, and trying to give some indication from a performance standpoint of what finishes will do over time and how they might change, especially remembering that zinc is not a painted material. It is a naturally weathered material. You can have a natural process using mill finish zinc, but pre-weathered zincs are not painted, so they do slightly modify, some slightly more than others. I mean, it's part of the attractive appeal, I suppose, of zinc.
So you're saying that a lot of the time architects are engaging in proper performance specification and requesting it, but is there a case that a large chunk of the industry still isn't quite on board, or there are pressures? What we're really talking about is the need to focus on the desired output from their standpoint of a material, in this case zinc, and not the input. So we're trying to push them away from over specifying the solution. Is that right? Leaving aside value engineering, generally, can you capture sort of what performance specification really is about?
Yeah, I mean, you're quite right. We're trying to get the end result correct, I suppose, is the bottom line. How can a specification be put together which gives what the architect and ultimately the building owner expects, without having to write out every single last element, and also maybe talk about individual products. So it is very much saying, right, well, this material will perform given, for example, certain wind loads or certain, as I said, requirements for aesthetics or requirements for durability, without necessarily spelling that out. Some of that goes through, as I said earlier, certification. Some of it even goes through British standards, European norms, codes of practice. Speaking of which, we're sort of trying to move codes of practice for zinc roofing and wall cladding forward, because some of them do date back a number of decades now, which is not ideal. They're not fundamentally wrong, but they're a little bit tired and old, let's say. But you're right. The ultimate objective here is to create a specification which gives an end result without the architect having to nominate every single little item, because that's something they shouldn't necessarily have to do. They need to tell people how it's going to perform, as opposed to all the dots and T's being crossed.
Is there sometimes a dichotomy between the people that maybe aren't so engaged, not providing enough on either the input or the output, and then the people who really think they know Vmzinc, for example, getting very, very into the weeds on the input side of things, when actually it would be much more appropriate for them to tell you in detail what they really want performance and management of the building wise.
Yes, no, that's completely correct. We sometimes can get into incredible detail about something which in the greater scheme of things isn't necessarily critical. We need to sort of look at the overall objective of what we're trying to achieve. An example is Zinc is very well known for standing seam roofing and cladding, but it's far from the only option, especially on walls. There's a number of different options, whether it be a rain screen panel or different types of shingles, or even things like corrugated sine wave sort of overlapping panels. All of which can fundamentally be made from the same material, but have very, very different aesthetics and will perform differently. So there are some things that we wouldn't necessarily recommend, and knowing what the architect and their customer are trying to achieve, not in every single detail, because that isn't necessarily something we're going to get told about, but overall what they're trying to achieve is useful when we're trying to support them with a specification that's going to do what they're expecting. So no, you're right. Being caught up in the details at some stage happens, and it is understandable. But having an overall more global idea of what the roof or the wall of the building are meant to be achieving is useful. Yes, absolutely. There are roofing contractors that will do a complete full build up for the roof, and then there are other contractors which are expert in rain screen facades, which will take on a different element. So if we know that helps us point the architect and the designer to where they should be going towards. As I said, horses for courses. You can get twisted up into sort of the tiny details. And we're talking about sort of different fixings for different types of flashings. Whilst this is all very important sometimes, it's more important to understand how the overall panel is going to be fixed than the tiny little detail. But we understand architects do want to get into the details sometimes, but as you said, having an overall understanding sometimes helps us push them in the right direction. A zinc roof or wall that's going to look attractive, last a long time, have very limited maintenance requirements, needs good design, but it also needs good installation. And when all these things come together, I mean, you can have a roof or a wall that's basically going to be up there looking great for maybe 100 years or even more. So the installation aspect is important, and that can be indicated in a performance specification by saying that people need to have a certain amount of training, they need to have a certain amount of experience. And some architects completely realize that and will state things in the specification saying this has to be done not just by an experienced zinc installer, but maybe it could be somebody who's a member of the FTMRC, which is the trade body for hard metal roofing, or they might have to submit a certain number of projects, or they might need to be a member of another organization. So it goes a little bit further than just a qualified installer, which in itself might not mean that much.
In terms of performance specification itself, you believe, am I right in saying that it's a way of actually guarding against the spectre of value engineering to an inferior offering done on a cost basis?
It certainly helps. I think the first thing on value engineering is to sort of say, what is value engineering? I mean, it traditionally gets better technical value. Unfortunately, over the years, it's been more turned into how can we do something more cheaply, spend less money on it, and whether it be an equivalent, whether it be technically, durably wise speaking, or anything else, sometimes becomes irrelevant. So true value engineering, I think most people would accept is absolutely fine. For example, there's an architect specifies an external fire requirement of a B roof T4 for the roof or the wall, and a product ticks that box, then that product could be considered. It's not just an equivalent, it actually has the same performance specification requirement that the architects put in their performance specification. One of the problems is that we do see, I don't know, it's slightly less, but we still see it quite a lot, is or equivalent. Now, or equivalent just opens up the floodgates, and people can just come in and really offer almost anything. And then who says if it's equivalent? Because or equivalent by itself really doesn't help anybody other than the person trying to go down lowest possible common denominator and just going down the price, whereas the value is irrelevant. It's just, we're just looking at the price per kilo, square meter, whatever it might be, which isn't really value engineering. So if you combine quality performance specifications with proper value engineering, they can work quite well in hand. When it's what we consider value engineering today, just what's cheaper, give me something that's cheaper, that's problematic.
Equivalent cost, rather than here's an equivalent product based on a set of slightly subjective assumptions. There's not really a body at the moment saying, yes, this is credible value engineering, right?
No, I mean, I don't think. You can obviously, look at the definition of value engineering, and it generally talks about value, but that's not the one that's applied. As far as, just sort of a word on products. There are very few bad products. There are some inappropriate products for some inappropriate uses, like there is for Vmzinc. Or any zinc. You can't do a flat roof in zinc, a completely flat roof. It doesn't work. That would be completely inappropriate. It's just the wrong application for the material. We do get asked about, can I use zinc on a flat roof? And we say, is it really flat? Sometimes say, well, no, it's actually 3 degrees. Well, that's not flat. And as long as it is 3 degrees, that works. But sometimes people want to go lower than that. They want to go to 2 degrees or 1 degree, which is really pretty close to being flat. And that's just not going to work. And the same thing with certain materials in a marine environment. You can put some materials in a marine environment and they perform very well, and others don't. It's not the product's bad. It's just it's an inappropriate use.
So in case of that, would it be the performance specification needs to be available, and you need to be able to sort of say, actually, that's not going to work in this particular way?
Well, you can have the marine category of it, which I think goes from C1 to C5, and that can be put into the specification if necessary. It can be combined with a durability or even a corrosion rate. That would be possible as well. So you know exactly where you're going with a certain product. Galvanized steel is steel covered in zinc, and once the zinc's gone, the steel starts to corrode, especially in a marine environment. And that's fairly well known. So that could be something that could be put into a specification. And then if somebody wants to change that through value engineering, they've got to put an equivalent. Now, if you used something like 316 stainless steel, that would probably do the job. If you use 304 stainless steel in a marine environment, it's probably going to rust. So that would be an example of one product that would work, another product in the same family that wouldn't.
So maybe we also need a stronger definition of what equivalent actually means.
Yeah, absolutely.
It's been interpreted as similar, isn't it?
Similar, yes, and unfortunately, quite often cheaper. There obviously a specification there is a combination of a written specification and drawings. You sort of have a tendency to say, right, well, we're just going to follow what's in the written specification, but it does have to be looked at with the drawings. So we have had examples of where the specification doesn't indicate a slope, and in itself, that's not necessarily a problem if it's clearly indicated on the drawings. But obviously, if the drawings don't indicate a slope and the specification doesn't, there's going to be a problem because somebody will get hold of it, possibly use the wrong the wrong material, or they'll use what's specified, but it's not going to do the right job. Build-ups are very, very important. We have 6 build-ups. Now, it doesn't have to go into an incredible amount of detail about every single last element of everything in the build-up, but there's certain things that can't be taken out. Again, that can be on the specification, or it can be on the drawing, or it can be both. So it doesn't need to be it doesn't have to be War and Peace, but we do see specifications. Sometimes there's a tendency of doing a copy and paste. So something was done on one project, and then it gets copied and pasted, but it's a slightly different project with slightly different requirements.
So there could be the wrong insulation thickness, etc., etc.
Yeah, it could be the wrong insulation thickness. I mean, an easy example is if you're putting a zinc roof on a swimming pool. Obviously, a swimming pool is a very warm and humid environment, and therefore the build-up has to deal with that. Now, we have a specific solution for that. So if somebody's done a school, which is just a normal school, which can have quite high humidity, but it's not that incredibly high humidity, and they put that onto a new specification of a swimming pool without thinking about anything else, then there could be a problem.
So sometimes it's about them understanding that you're going to come back to them with queries rather than the other way around.
We do get sent quite a few drawings and specifications, indeed, by architects. And whilst we can't review a complete project from foundation, but what we're more than happy to do is to look at somebody says, is this build up correct? We can absolutely review that, and we'll say, right, well, for this building it's fine, or it's not, and we would recommend this. So a relatively early review process we recommend. Height issues on buildings are quite often critical. So depending on what build-up you might want to do can affect the height of the building, maybe not by more than 5 or 10 centimeters, but if you've gone to the max in the planning, and then somebody says, well, you've got to add another 10 centimeters, it can create a bit of a disaster. Whereas if that's looked at early on, it's a lot easier to deal with. And this isn't about talking about product names. This is getting, as you said at the beginning, this is about getting the specification right for the building in question, especially if you're using certain insulation types which might have very high fire performance. They might be a sort of A1 non-combustible, but they might not have quite the same U-value performance. And therefore, if somebody's wanting to have non-combustible materials or limited combustibility materials in a build-up, that can affect things as well.
So work together with yourselves and come up with a robust performance spec. Is that the initial goal?
Yeah, I mean, we want to have people saying, right, well, what's the I mean, without going into sort of the Grenfell question immediately, but we want to say, well, what are the requirements of from a fire perspective? What can and can't be done, because there are buildings, if you're doing an extension, a 1-story extension, unless the building owner wants to use certain products, which is absolutely their prerogative, there might not be any sort of issue with a PIR type insulation. It's absolutely fine. As I said, that could be the building owner might want to use something different, and that's fine. But that's not going to be the case on an 18-meter facade. So again, being able to make sure we do the right thing for the right project is very important.
So just moving briefly on to post-Grenfell and the lauded golden thread approach over 18 meters, but includes this important change management process, right? Which really helps to avoid the traditional Wild West phase of value engineering. Is it being reduced?
In all honesty, I'm not sure it is. One of the problems here are resources. And being able to make sure people, follow the requirements, which is quite onerous.
Because basically, you've got the building safety regulator vetting these submissions at Gateway 2.
I think getting that sort of through in a timely fashion. I don't know the exact timeframes, but it's very, it takes a long time. So making sure things are done correctly. I mean, there's no excuse for saying, right, well, can we do it a bit quicker, but we'll take risks. That's just not not acceptable. But if somebody is doing the right thing, is it fair to then have to, wait weeks and months trying to sort of to somebody to say, yes, this is okay? I'm not sure that really works either. It can happen that contractors will say, right, well, I'm going to, offer this instead. And it's not really been investigated in great detail whether this instead is going to follow the performance requirements, and that's where we still see undoubtedly products being changed which might not have all of the requirements that the architect and building owner wanted. I think it's really too early to say at the moment, unfortunately, whether this has made any a significant change.
Have you seen Zinc switched out on projects in the last few months?
We have. Yes, we have. I mean, we have to be fair. There are going to be scenarios where an architect specifies a zinc roof or a zinc wall, and it goes through the process, and for some very legitimate reasons, it changes. That can happen, and will always happen. When it's a little bit there, somebody is forcing it because of, unfortunately, so-called value engineering, saying, well, I can do this cheaper, and not talking about what the performance is, whether it be from a fire perspective, whether it be from a durability perspective, whether it be an aesthetic perspective, then that's it's not really good for anybody. I mean, it's a short-term gain for a contractor maybe, but it's pretty short term. It threatens the whole what might be happening, if something does go wrong. The legitimate changes will always happen, and that's just what might be required on the project in question. But there are ones, to answer your question, in recent months there have been projects which have been value engineered for no reason other than purely, well, this product does the same thing. Well, it doesn't really, and it's cheaper. Well, yes, it is. An architect specified a build-up with a B roof T4 fire exposure, and that build-up says, with the zinc, says it passes, and something which hasn't got a test then gets installed. Now, who knows if it's going to pass or not, but nobody's proved it. So there's something which has completely deviated from the performance specification. And you could, on the same thing on durability, the architect might have put something in the specification about durability and referring to, for example, the BRE, which state 100 years serviceability, and another product's come in and there's no mention of that. So there are instances where there are specific changes in what gets used which do not follow the performance specification. When it's completely out in the open, everybody knows about it. The building owner, the architect say, okay, now we've had to make this change for whatever reason. Then that's sort of a situation where, well, everybody knows what they're getting. Fine. It's when it's sort of done in a slightly underhand way. Well, we'll offer this product. It's effectively the same. Or it's an equivalent, and it's not really, and it sort of goes underneath the radar. I think the important thing here is clarity for all the players, especially the architect, because they're the person who will have written the specification, to be aware of what's being offered. And if something different is being offered, and they say that's fine, I'm happy with that, I know the differences, then that's absolutely fair.
Because of our fragmented industry, we haven't fixed that yet.
Not entirely, no.
But trouble is, it adds time, doesn't it? It adds cost.
Yes, it does. I mean, it does add time because when people have got it's got to be transparent and it's got to be explained. Who do you explain it to, and how long do you wait for the information to come back? That is tricky. But transparency, I think, whether you're talking about performance, whether you're talking about golden thread, whether you're talking about gateway 2, or you're just talking about somebody doing an extension and on the back of their house. When it's transparent and clear, things generally work quite well. Whether it's to make a change or not make a change, but when it's transparent, we're sort of everybody's in a much better position.
And then last but not least, we talked about installation. Products are only sometimes as good as the install. And the Federation of Traditional Metal Roofing Contractors is obviously heavily involved in quality. But you're also doing something called the Vmzinc at Work program. Could you try and explain a bit more about that?
Yep. I mean, you're completely right, James. And as we discussed earlier, installation is very, very important. And we recommend recognized installers, contractors that have got a prior track record that can show that they've gone through certain training programs. And the FTMRC members are experts in hard metal installation, hard metal being not lead, which would be considered a soft metal. So, and probably the majority of them fit zinc on a regular basis. And so we've been working with the FTMRC on a number of levels, technical seminars for since its inception, which is almost 20 years ago. Before that, actually, we had a program which started off in France, probably in about 1993 or 4, called ProZinc, which was designed to train installers, and that's expanded beyond France into Belgium, into Germany as well, and a number of other countries. In the UK, we started something called Vmzinc at Work, which is a partnership with members, sometimes of the FDMRC, but there are others. And these are installers that we have a closer contact with. We do presentations to on a fairly regular basis. We give them information about, for example, the build-ups. A lot of installers now realize that even if they're not fitting the substrate, they're responsible for the substrate, because if they come along and fit a metal on top of something which isn't suitable, it's really their responsibility to say, no, there's a problem here. So the installers knowing about the substrates is very important, as I said, whether they fit it or not. And so we've got a Vmzinc at Work, I think, is about, in the UK, it's about 12 years old now. We've got just over about 65 members across the UK and Ireland.
These improved installers, effectively.
Effectively, it's a sort of partnership. I mean, they're not part of they're not the same company, but their companies can receive a 50-year material warranty, project based. So we get the information, and then we issue a warranty for that project. It's very much a partnership between these installers, these contractors, and ourselves.
And then you also mentioned the ProZinc. Could you tell me about how this has become a UNESCO protected thing, the more established European training network?
As I said, ProZinc started over 30 years ago, and not just Vmzinc and ProZinc, but a number of other organizations have been involved in Paris for sort of 10 or 15 years to get zinc roofs, which maybe not everybody notices or knows that they're zinc, but 95% of Parisian roofs have zinc on them. It's a sort of a very iconic material in Paris. It's something which is sort of quite striking. Most people will see them, but they probably don't know what they're looking at. But they'll say, "Oh, that looks like a typical Parisian roof." So 10 or 15 years ago, we got involved with a number of other organizations to get the rooftops of Paris, the zinc rooftops of Paris, put forward to get UNESCO World Heritage status. For various reasons, that didn't quite come about, but what did happen is the skill of the zinc roofer and the people that fabricate and install ornaments has become part of UNESCO World Heritage. So that happened at the end of November 2024. The zinc roofer is officially World Heritage status. And although it's for Paris, I think all zinc roofers around the world can sort of take some pride in that the skill of a zinc roofer actually has UNESCO World Heritage status, which is, I think something to be quite proud of. Whilst London and other UK cities don't quite have the Parisian roofscapes, let's say, there are some very, very interesting zinc-clad buildings in the vast majority of UK cities and towns. It's not something that's used like it is in Paris. Have to be honest there, but there are lots and lots of projects which can be seen across the UK and Ireland.
It's still seen as a bit of an exclusive or high-end material, isn't it, in the UK?
Yeah, I mean, in the metals family, it's really sort of mid-range. I mean, lead and copper are more expensive. Aluminium and steel are less. Stainless steel's probably a little bit more as well. So sort of zinc, sort of, in the middle of the metals. There's always going to be something that's more expensive. There's always going to be something that's less expensive. Sometimes zinc is considered very expensive. Maybe it's because it's considered a high quality material, so people sort of put a big number on it.
Well, that's an important misconception.
Again, it comes back to getting the right product for the right roof, and without sort of saying it all over again, there are no bad products. It's just, what are you trying to do with your building and the materials you want to use on it?
Thank you very much, John. We've slightly overstayed our welcome, so hopefully we can do this again.
Thank you, James.
Speak to you soon.